Hi guys, this is Miss Pruitt, and I'm coming to you guys with number 2 of from our worksheet that we were working on today, the concepts worksheet 3.6b. You should have gone ahead and already have read number 2, and I'm just going to go through and try to dissect what it's actually wanting me to do. First of all, of course, I know I'm sketching a graph. It's telling me that it is a continuous even function. We talked about even and odd functions today. Remember, an even function is symmetrical about the y-axis. Or you can say that if I were to put a mirror on the y-axis, it's reflected on both sides. It says that it is on a closed interval of x values. So my leftmost x point or x value will be -5. My rightmost would be 5. And it has a range, from bottommost to topmost, values of -1 and 0. For all of my x values that are positive, the roots, talked about that also, the roots of g of x equals 0 happen at every whole number, and they're going to use k. Every whole number k is going to be a root. And we talked about roots earlier. A root is the same thing as an x-intercept. And the roots of g prime of x equals 0 occur at k divided by 2. So let's really take a second and see what this is talking about. The roots of the first derivative equals 0. Well, recall from class, anytime that my derivative is equal to 0, right, I'm going to have, that's a critical point. Something is going on at that point. And it's saying that it's happening if we found out that our whole number was k. This is happening every time k is divided by 2. Or for every whole number, right dead smack in the middle of it, I'm having a critical point, or something's going on at that point. Also, it says the first and the second derivatives of g of x exist everywhere except at x equals k. Remember, that's one of my roots. So my equation or my graph is going to exist everywhere except at every single place that I have a root. Well, what would make my first and second derivative not exist? That means if it's not existing, it is not differentiable at those places. It is not differentiable. So things that are not differentiable are cusps and sharp corners, right? These are continuous, but they are not differentiable at that point or at that point. Then it says, furthermore, g double prime of x, or the second derivative of g, where everything is positive, it says, g prime of x is greater than 0 for every x value that does not equal k. So everywhere else besides those roots, my second derivative is greater than 0. Well, like we learned from class, second derivative tells us what about the original graph? Concavity. So this is telling me then that for every single value that's not my root, it's going to be concave up. So let's see if we can try to put all of these different things together into one graph. All right. So I know I'm only going from -5. 5 not going any further than that. I am going to have an intercept. Trying to get as close as possible. I'm having an intercept from there to there. From -5, I'm going to put a -5 right here. We can put a -5 right there. From -5 to +5. That's my domain. I also know that my range, let's pick another color. It told me that my range was -1 to 0 only. It also told me, let's use this. Let's say we took care of that. It says that g prime of x equals 0, or I have a horizontal asymptote in between every k value. And the k values are just the whole numbers. And also it's going to be concave up. So in order for me to fulfill all of these requirements, my graph will have to do this, 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 Miss Pruitt, you're not going down far enough. This, and this. Just make sure that yours is a little better than mine. Let's see. I want to make sure that I'm going all the way down to -1. Notice at every single, hopefully this is better. Oh, Miss Pruitt. That should go down there. Whatevs. Alright, so hopefully you guys get the idea of what I'm trying to draw. Notice that in between, because like every one of these whole numbers in between, right? That would be the middle between this -5 and -4, right? That is, I'm getting that from the clue that my first derivative should come down here, is equal to 0 at every midpoint of k. What else? Also, look here. Each one of these points is coming up to a sharp point or sharp corner like this, which makes it not differentiable. And that's how I satisfy that the first nor the second derivatives exist. And that's pretty much it.